is a pressure regulator for liquefied petroleum gases, such as natural gas and propane. In this video, we'll take a close look at the mechanism inside to see how it works. Before we jump into the inner workings of a gas pressure regulator, let's first look at the key components involved. Let's get started. Pressure regulators are critical components used with gas appliances. They reduce the inlet pressure from high pressure sources like tanks or pipelines to the desired lower outlet pressure suitable for applications such as heating and cooking. They serve as essential safety devices by maintaining a steady outlet pressure to the appliance, regardless of fluctuations in the inlet pressure, and automatically cut off the gas flow when it reaches a certain pressure, preventing pressure spikes. This is the inlet port where high-pressure gas enters the regulator from the tank or pipeline. This is the outlet port, where the regulated, low-pressure gas exits the regulator to supply the appliances. This is the vent. It performs two important functions. First, it facilitates proper regulation of downstream pressure by allowing the regulator to breathe. Second, it enables the release of excess gas pressure into the atmosphere. If the vent becomes blocked, the regulator won't function properly. That's why there's a screen in place to keep insects out, as they can build nests in the vent and obstruct the opening. Furthermore, it's essential to install the regulator with the vent opening facing downward. This orientation helps mitigate the risk of rain, snow, or debris entering the vent. This is the seal cap. Removing the seal cap gives access to the adjusting screw inside the regulator body. Turning the adjustment screw clockwise increases the outlet pressure, while turning it counterclockwise reduces pressure. Now let's take a close look inside the gas pressure regulator. This is the diaphragm, the pressure sensing element, a flexible membrane that moves up and down in response to changes in pressure. Connected to the diaphragm is a lever with a rubber valve disc at the end. This is the pressure control element, which controls the flow of gas entering from the orifice. This is the main spring pushing against the diaphragm. When you turn the adjusting screw, you are essentially compressing or releasing the main spring. This increases or decreases the force applied by the spring on the diaphragm. This is the spring-loaded relief valve, which releases excess pressure. Now, let's understand how the gas regulator works. As gas enters the inlet, it passes through the orifice and into the regulator's gas chamber. This increases the pressure under the diaphragm, pushing it upward and compressing the main spring. As a result, the upward movement of the diaphragm brings the valve disc closer to the orifice, thereby restricting the flow of gas entering the regulator. When the outlet pressure decreases due to gas consumption from the appliances, the pressure under the diaphragm also decreases. This causes the main spring to push the diaphragm downward. Consequently, the downward movement of the diaphragm disengages the valve disc from the orifice, allowing for an increased flow of gas into the regulator. The regulator continuously adjusts the force exerted by the spring to counteract the gas pressure, ensuring the maintenance of the desired outlet pressure. When the pressure under the diaphragm exceeds a safe limit, the diaphragm's upward motion eventually opens the relief valve. This allows excess pressure to be released through the relief valve, then through the vent orifice, ultimately venting outside of the regulator. Once the excess pressure is relieved, the valve spring closes the relief valve. The pressure regulator shown in this video is a single-stage regulator that reduces the pressure from the supply line to the desired level in a single operation. Some applications require a dual-stage pressure regulator, which employs two regulators within the same body. This design reduces the pressure in two stages instead of just one. The first stage reduces the inlet pressure to an intermediate level. Then, the second stage further reduces the intermediate pressure to the desired outlet pressure. Dual-stage regulators are typically employed in applications where there is a considerable distance between the gas source and the appliance. I hope you found this video informative and interesting. If you did, don't forget to give it a thumbs up and subscribe.